Milani, Chapter 16, Section 1. In this section, we are going to talk about integration by part. Now, sometimes when you are trying to find the antiderivative, we talk about it on the 15.1. If I don't have a product rule, quotient rule, or the chain rule, you get the antiderivative as is. In 15.2, we talk about it. If you have a quotient rule, chain rule, product rule, then you have to go by the substitution. The problem I created for you on that section was the problem 100% was working if we were using the substitution. But sometimes substitution does not work. Then you have to go by integration by part. Integration by part is going to be two different methods. The first method is going to be a standard method. The second method is column method, which I would cancel the column method for you guys. We will just talk about the integration by part by the standard method. Now, there is a formula which you have to memorize it. The formula is going to be uv minus antiderivative of a v du. Now, again, anytime you are looking at any of my integrity, the first thing you do, you just watch the entire problem, and then after you watch it, then get your notebook and then piece by piece watch it and then copy it. Now, the first problem, I have an antiderivative x e to exponent x. Now, listen carefully. This one is the product rule. And we already talked about it in 15.2. If I have a product rule with the exponential function, exponent from the exponential function is become u. That means in this problem, I have to say x is equal u. It does not make sense at all if you substitute a letter by a letter. That means you cannot say u is equal x. You can say u is equal 2x or u is equal x to exponent 2, but you cannot say u to the exponent 1 is equal x to exponent 1. That means by looking at this problem, u substitution does not work. I have to go by the integration by part. Integration by part, you are going to make your problem as a two-part problem. One part, you get the derivative. One part, you get the antiderivative. Now, just look at it. This is the hint I can give you. The part you choose it for the derivative is going to be the part which first derivative or second derivative or the third derivatives eventually is become 0. Then, look at here. I have a product rule. I have a two-part. Now, if I choose the x, the first part, as my derivative part, that means derivative of a x is going to be 1. Derivative of a 1 is going to be 0. Perfect. But in case, if you are confused, you are going to say, you know what? The second part, if you use it as a derivative part, Derivative of e to exponent x is going to be e to exponent x. Second derivative, e to exponent x. 10th derivative, e to exponent x. That means no matter what, there is no way when you get the derivative of e to exponent x, you are going to reach 0. But we talked about it already. If I choose the x, yes, I'm going to reach to 0. Then u is going to be my derivative part. Now, I'm going to say u is going to be my x. But remember, I am not substituting. I am using the u as a x. Now, the second part, it doesn't matter if you are going to write it down dx with it or not. That's the reason I underlined my second part. My second part is going to be my antiderivative part. I'm going to use the v as my antiderivative part, which is v is going to be equal e to exponent x, or you can say e to exponent x dx. It doesn't matter. Now, from the derivative part, get the derivative. Derivative of a u is the du, derivative of a x dx, or you can say du over dx is equal 1 and then cross multiply. The antiderivative. Remember, by looking at this one, when I had the u, the derivative is become du. And then, if I have a dv, now, if I have a dv, the antiderivative of a dv is going to be v, and antiderivative of a e to the exponent x is going to be e to the exponent x. Now, by looking at my formula, I have everything. Now, you just plug everything on your formula. U. My u is going to be right here, is the x. V. My v here is e to the exponent x minus antiderivative v minus antiderivative of a v is e to exponent x du. Du is dx. Now, look at it. My antiderivative part is so simple, I can get the antiderivative. This first part, carry it down as is. Antiderivative of e to exponent x is the e to exponent x. But again, don't forget, I'm going to carry it down the first part. This minus, I'm going to carry it down. Antiderivative of e to exponent x is the e to exponent x. Don't forget, in the end, plus c. This is ready. This is clean up. That means I got the antiderivative of this problem. Which again, this is the simple way. The only thing you have to do, just memorize this formula and plug it in. As I talk about it, we do not talk about the column method because I cancel it for you guys. That means almost half of the 16.1, I will cancel it for you guys.